Hi everyone. So what happens when Terraform drift occurs? Instead of us coming and trying to resolve the issue, if an AI was there to resolve it and by detecting the Terraform drift and doing the required changes if the risk is not too high. But if the risk is high, then of course approval should be there in place. But our work will become easy, right? Before everybody knows your AI is resolving the issue and or getting you the solution, detecting the drift on time before your organization starts working. So will that be useful? Of course. And nowadays, when this question is asked that how do you tackle with Terraform drift, just telling that we will run few commands and we'll try to resolve the issue, uh, that just looks like that you have not actually worked and you have not ever thought of the solution apart from manually running the commands. And Terraform drift is an is a situation which should be not just we should not depend on just we should not just rely on running some commands and then knowing it and then trying to resolve it. So let's try to see what all we can do and what all commands are majorly used in Terraform Drift and what is Terraform Drift if somebody is new and has came to see this video. So yeah, without further ado, let's start this video. So I was going through this one blog of HashiCorp of detecting and managing drift with Terraform, and it's one of the most useful document. You can study, like there are many examples given that how Terraform will tackle these situations in case of drift. 2 3 scenarios. So first of all, if after like before discussing about this, what is drift? So drift is basically the term when the real world state of your infrastructure differs from the state defined in your configuration. So whatever we have in our code and what is actually present on the cloud or in your infrastructure, there is some difference. Like we are not tracking that resource, or there are some changes which are done manually and that is not being tracked in the code. So yes, our code and the real world infrastructure has some difference, so that is a drift. So what majorly plays a role to detect the drift is basically the Terraform state file. So all the tracking which is done of the resources created by Terraform is kept in Terraform state file. So what all commands we actually should use to detect and manage the configuration drift is, first of all, we should have the Terraform state file. Unless until we don't have Terraform state file, we won't be able to detect the drift. Terraform refresh, so the refresh command and reconciling real world drift. Terraform plan, basically after refreshing the plan will show that what all data that has been captured, what is matching and what is not matching, and now what is the plan, what Terraform will do, likely want to do. So basically if there are 2 3 scenarios which we'll see. Suppose there is a instance on which the tag was v1 tag. So this is an instance. So earlier, like in our code, the tag is given as v1, but somebody manually changed it to v2, okay, on the cloud and something. And when we run the Terraform plan, we'll see that it will say that this Terraform will perform the following action. It will say that it will revert the change. So some changes Terraform can do, it can modify, it can correct the drift. So it will say that it will revert the change to what we have in our code. But some of the changes Terraform cannot do, like here what it did. So it Yeah. So it will revert the change to v1 again if we say Terraform, if we go with Terraform apply and say yes to it. Now what happened, that there is another instance where somebody manually updated the AMI of the instance. In that case, when we run Terraform plan, what it will do, it will destroy the instance which is already running, and it will then create a new instance with the AMI present in our code. So this is what Terraform does, like in the cases when it will destroy the already some for some scenarios it will try to change, but for some scenarios it will try to destroy and create it again. So that is one fix that it does. So in case if you don't want to destroy something, some instance, and you want to retain the changes already done manually, in that case there is life cycle option. So there are life cycle option of prevent, destroy, or ignore changes that we need to do, that we can ignore the AMI. In that case, whatever if you are ignoring, that will not be considered and no changes will be detected. So this is the blog I was telling about, so that you get a clear understanding about what is Terraform drift and how in some scenarios Terraform detects it, and I will paste this document in the description box. Now let's see, the main agenda is how we can create a Terraform drift detector. And basically we have used OpenAI to analyze the drift report, the JSON, and then suggesting the remediation. And there is Python code to create that whole AI. So let's see. So before going to to the code, we'll see the architecture diagram. So basically, there is a script run.scan.sh, which is the main script, which is the entry point. So that script we can schedule as a cron job, or through GitHub action it should be scheduled to run, or through Jenkins pipeline we can schedule it to run every day at specific time, or at a Kubernetes cron job we can make it run. So basically this script will run and it will call main.py Python code, which will load config.yaml. It's the central configuration that what will be the working directory, so like that. And after it will call the Terraform runner.py, where we will run the Terraform plan, Terraform show JSON. So basically we'll see what is the drift, to detect the drift. Then we'll after detecting the drift, if there is a drift, it will create a JSON output. So basically now the drift will be detected using drift dot parser. So whatever drift dot JSON is created, it will go into another Python code, drift parser.py, and it will detect that if the drift is there or not. If it is there, then it will go to OpenAI analyzer, where it will use the model OpenAI GPT-5, and according to the JSON that it got, so it will analyze that what is the output and everything, and according to the JSON it will try to get the severity, intent, and risk. And after that it will, whatever according to the risk or according to the output, it will try to suggest an remediation. So it can suggest that you can do this and it will solve the issue, and you can run this command or do so. What according to the drift, it will try to suggest a solution. Okay. So basically we have this Terraform drift detector folder, under which we have this app folder, and under app folder we have all the Python code. So you can I'll give the link in the description box. We'll see the main.py file, where it is first of all importing the class from Terraform runner drift parcel, that Python code. After that it will try to first check for config.yaml. Then after getting, it will run the Terraform scan commands, plan command, and everything, and then it will call the drift basically the drift parser. So accordingly it will generate the JSON, and after the JSON is generated, it will call it through OpenAI analyzer. It will try to detect the the severity and intent if the drift is detected. So this is how our main.py will work, and these are all drift parser.py, how it is converting the JSON into proper readable format of OpenAI analyzer. This is models.py. So basically how the uh, how it will store like severity, intent, risk, explanation, remediation, script, everything. And then this is OpenAI analyzer for just calling the giving the prompt to OpenAI that determine the severity, intent, risk in this form, and then whatever response we'll get, this is a remediation generator. So it will call the remediation script and all that. And Terraform runner.py. So basically it will run Terraform plan refresh only. It will try to give the output. So this is all the code, and basically the running script I have created the requirements.txt. So basically we can build this code and try to deploy it so that we can check the running status. And this is the Docker file that I've created for this, and we can use this. We can also create the CICD YAML to trigger the scan, to trigger the so this is a script of run.scanf, which is not doing nothing, just calling the main.py. And this is our conf. So that's it for today's video. I hope it's helpful. Please let me know views in the comment section. Till then, take care. Bye.